So far, all of the forms of energy that we've talked about in this unit have had one important thing in common. They all relate somehow to matter. The three types we talked about first, the ones that are atomic forms of energy, need to exist in the parts of atoms. And because atoms are what make up matter, you can't have those three forms of energy without matter. The same goes about the moving types of energy, because those were all related to moving atoms, and once again, without atoms, you can't have matter. So because all of those forms of energy required atoms in order to exist, all of those forms of energy only exist in matter. Are there any forms of energy, though, that exist apart from matter? Yes, there is one form of energy that can exist in nature without needing matter, and that is electromagnetic energy, energy that does not need atoms in order to exist. Now, you should be pretty familiar with the definition of energy at this point. Energy is the ability to cause a change, and we talked about the different kinds of changes that are energy, pretty much any change you can envision. And in this lesson, we're going to be talking about energy that exists apart from matter. Most of the forms of energy are energy that exists in matter, but electromagnetic energy doesn't need matter to exist. And in fact, that's the primary thing that defines what electromagnetic energy is. It's energy that can travel through empty space even without matter. There's a pretty simple way to prove that electromagnetic energy has to be one of the types of energy. Think about the sun for a moment. How in the world does the sun's energy get to the earth if in between the sun and the earth there's a whole bunch of empty space? Because that empty space isn't made up of atoms, there's no way for any of those forms of atomic energy or moving atom energy to get from the sun to the earth. So how does the sun do it? How do we get energy from the sun to the earth? Well, it all has to do with electromagnetic energy. The sun produces so many different kinds of energy, it actually produces a huge amount of electromagnetic energy. Light and radio waves and X-rays and infrared radiation and ultraviolet radiation. And some of those forms of electromagnetic energy are able to travel beyond the surface of the sun. They go out into space and they reach the earth. That's what electromagnetic energy specializes in. It's able to travel even through empty space. So there's a simple proof that electromagnetic energy has to exist. It's the only way that we could get the energy from the sun through outer space. Here's the thing about electromagnetic energy, though. There's not just one type, one simple brand of electromagnetic energy. It actually comes in several different types. And for our purposes, it's not really important that you understand the different types of electromagnetic energy and exactly what they are, but that you understand what all of these types have in common. Electromagnetic energy, regardless of what type it is able to travel even through empty space. Now you're going to see that the different types of electromagnetic energy carry different amounts of energy as they travel through space. And they're used for different things because of that. But the thing they all have in common, they can travel through empty space. So some forms that you're probably familiar with. First of all, radio waves are electromagnetic energy. Radio waves are really long waves that don't really have a lot of energy, but they can travel an immense distance through space and even around the matter, like air particles and things that radio waves travel through. So you can turn on a radio with an antenna, and that antenna is able to pick up radio waves from a huge, huge distance away, pick up the signal, and it knows what sounds to play from the speaker based on the radio wave signal that it's able to receive. Another form of electromagnetic energy that you're used to using, even if you didn't know that you were using it for this purpose, is microwave energy. Now, you're used to hearing about a microwave oven, which, yes, microwave ovens do use microwave electromagnetic energy to heat up food. However, did you realize that your cell phone also uses low energy microwaves to transmit a signal to a cell tower, and it receives signals from a cell tower also? So your phone is able to transmit messages by using electromagnetic energy. Now you'll notice that these two uses of electromagnetic energy have something in common. They're both being used to transmit a signal, to send information, the sounds to play on a radio or the sounds to play on your speaker on your cell phone so you can hear somebody talking. The reason why electromagnetic energy is so useful is because it can go over extremely long distances and carry a signal that doesn't lose a lot of its integrity, but also electromagnetic energy travels at the speed of light. So therefore, it travels very, very quickly, and you can talk to your friend on a cell phone and they will hear you moments later because that signal gets transferred so fast. Sound does not travel very fast, but light can travel immensely fast, and that's one reason why electromagnetic energy is so useful for signals, for radio waves, and for cell phones. Another type of electromagnetic energy that has even more energy than microwaves is infrared energy. Infrared light has a lot to do with thermal energy because things that have a lot of thermal energy tend to also radiate electromagnetic energy away as well. So you can use an infrared camera to look at the outside of a home, and where you see hot spots in the infrared band, you know that maybe the home isn't insulated that well there because it's giving off a lot of thermal energy to the outside, and you can see the infrared electromagnetic energy that accompanies that. Another important form of electromagnetic energy with more energy yet is visible light. This is an important form of electromagnetic energy because this is the type that your eyes are designed to pick up. All of the colors and all of the things that you're able to see, you're only able to see those because your eyes are designed to interpret that kind of electromagnetic energy and make sense of it. With even more energy yet, ultraviolet light is another form of electromagnetic energy. This form, though, can be absorbed by the matter in your skin and can actually change your DNA. So ultraviolet light is not good for you. You can use it for tanning, but it also can cause bad things to happen with your skin, including cancer, because it affects your DNA. So now we're getting into forms of electromagnetic energy that have enough energy to harm you. Let's take a look at the next one. X-rays are another form of electromagnetic energy with even more energy yet. X-rays are helpful for us because they penetrate right through your skin and soft tissues, but they're absorbed by your bone. However, X-rays also have the potential to change your DNA, and therefore you don't want to be around X-ray radiation all the time. In fact, many times when you get an X-ray, they'll cover your chest and other soft tissues with a lead vest that protects them from the X-ray radiation so you don't receive too high of a dose. Another form of electromagnetic energy with even more energy than X-rays is gamma radiation. Gamma radiation is used to treat cancer. We focus gamma rays on cancerous tissues in the human body because it has the ability to kill cells in the human body. And then finally, the last type of electromagnetic energy with the most amount of energy is cosmic rays. We don't encounter cosmic rays very much here on Earth because we are protected by the Earth's magnetic field. However, cosmic rays are very common in outer space. So if we did send an astronaut to the moon for a long period of time or on a manned mission to Mars, we'd have to somehow shield them from cosmic radiation. Otherwise, their body tissues can be harmed by that type of radiation. So now you know a little bit more about electromagnetic energy. There's a lot of different types of electromagnetic energy. They have different amounts of energy. They're used for different things. But the big thing to note is that all of these forms of electromagnetic energy are able to travel through empty space even without the presence of matter. They can interact with matter, they can be absorbed by matter, and actually matter can give off electromagnetic radiation. But they don't need matter in order to exist.